Hi, friends. Hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about ASCII codes. We are going to see alphanumeric codes. Last class we have seen what is XS3 codes and what is gray codes, and we have seen how to convert binary to gray code and gray code to binary. And today we are going to see what is meant by ASCII codes, what is the importance of ASCII code, how to represent ASCII code in binary, and what is the equivalent hexadecimal number, and all those things we are going to see. Okay, so first let's see what is ASCII code. So ASCII code is normally used to represent alphanumeric numbers, that is alphabets, numbers, special characters, everything can be represented in computers using ASCII codes. Okay, and ASCII is American Standard Code for Information Interchange. An ASCII code is normally represented as 7 bits, right? It is 7 bit. So the total character is 128, that is 2 to the power of 7. So it is 128. And you can represent uppercase and lowercase alphabets, numerals, punctuations, printing and non-control characters. You can represent everything in ASCII codes. Okay, and if it is say 7-bit code, okay, so we represent it as 7-bit code. For your understanding, நீ எப்படி புரிஞ்சுக்கலாம் அப்படினு பாத்தீங்கன்னா 7-bit code na you consider like this 8421 and 421. So this is 7 bit. So first 3 bit வந்து பாத்தீங்க அப்படினா இதுல represent பண்ணலாம், right? And 421 ல represent பண்ணலாம். And similarly next one the 8421 code, that is 7 bits totally. So first 3 bits represent பண்றது 421 னு வெச்சுக்கோ, and remaining வந்து 8421 ஞாபகம் வெச்சுக்கோ, right? So 2 to the power of 7, that is 128 symbols can be used. Okay, and now as I said before, you can represent alphanumeric numbers, that is alphabets, numerals, special characters. Okay, and you have a special representation for all the alphabets and numbers, that is you have to represent A to Z, that is if it is capital A to Z, then you can represent using ASCII codes only by this way, that is 41 to 5A, right? I'll show you what is the representation in the chart. A will start from 41, A oda value enna 41, B oda value enna 42, C oda value enna 43, right? Similarly it goes on, right? And Z oda value enna 5A, right? And if you don't get confused with 5A, I'll show how it works. Okay, and similarly for smaller A to Z, it starts from 61 and it ends at 7A, right? And similarly for numbers 0 to 9, it starts from 30 and ends at 39. Okay, and now you see this is the complete ASCII codes, right? What is the decimal value, what is the hexadecimal value, how the ASCII characters are represented. Okay, and now you can see here, if it is ASCII A, in ASCII characters it is A, then for computer it can be represented as 41, that is in hexadecimal value it starts with 41. Okay, and that is why if it is A, we call it as 41 in ASCII. Okay, and we say that from A to capital Z it is 41 to 5A, right? So how it represents 41, 42, 43, 44, 45, 46, 47, 49, and you can see here now it is an hexadecimal number, right? So it will not go to 50 now. Now it goes to 4A, 4B, 4C, 4D, 4E, 4F, right? And similarly now it goes to 50, and similarly it goes 51, 59 up to 59, and then 5A to 5F, right? And similarly you can see it starts with 60 and till Z it follows the same principle, that is you can see till Z it is 5A, right? So even for small alphabets, right, smaller alphabets, A, you can see it's 61, it starts with 61 and it ends at 7A, right? So it is very clear that if you want to convert any particular characters to binary, you have to use this particular representation. Okay, that is you got to understand first what you have to do is you have to represent that to an hexadecimal number. That hexadecimal மாத்தணும், அதுக்கு அப்புறம் அந்த binary value மாத்தணும். For example, A என்ற நம்பரை எப்படி ரெப்ரசன்ட் பண்ணலாம் ASCII ல 41 ரெப்ரசன்ட் பண்ணலாம். அப்ப 41 நீ பைனரியில எப்படி ரெப்ரசன்ட் பண்ணலாம் உனக்கு தெரியும். Right, by 4 and 1. Right, similarly like all these digits can be represented. Okay, so I repeat it again, from A to Z it is represented using 41 to 5A, and similarly for A, smaller a, it will start from 61 to 7A. Right, and for numbers you can see it starts from 30 to 39, and even special characters it can be represented. Okay, so this is the ASCII conversion actually. Okay, and now you can see that very clear representation. For example, if you say yum, right, if it is yum, you can see here, if it is smaller yum, it is represented as 6D. Hexadecimal, it is represented as 6D. Right, you can see it is represented as 6D. Right, and if it is binary, right, if it is binary, what you will do, 6D, how will you represent? You got to represent 6 separately and D separately. Right, if it is binary, you will use 8421 code for both the things. Right, you can see this is 6 0 1 1 0, and D is something, D is 13. Right, so 13 how can we represent? It is 1101. Correct. And now for 7-bit, 7-bit is nothing but the ASCII representation. The ASCII representation, what we will do, we will use 421 and 8421. Right, so how will you represent 6 here? 1 1 0, and D is same thing. Right, you can represent it 13 1 1 0 1. You can see here, this is what we represented, 7-bit. Okay, 7-bit is nothing but the ASCII characters. Right, similarly any particular numbers, any particular number, you can represent the corresponding binary, decimal and ASCII values for that. Correct. So any particular conversion, you have to first understand, if a letter is given, first you have to understand whether it is capital letter or small letter, and then you have to find out the corresponding hexadecimal value, and then you have to convert that hexadecimal value to the corresponding binary value, so that you can easily represent in other representation. Right, now you can see one particular problem, ASCII codes, you can see electronics. Right, so electronics, if this particular electronic, convert this, write this ASCII code for electronics. How will you represent ASCII code for electronics? Right, so what is the first step? You need to write it in hexadecimal. Right, as I said, what is E? Go to the chart, you got to find out E. E is nothing but 45. Right, so it is 45, and for L it is 4C, and for E again 45, and for C, and again it is 43, and similarly like this. Right, this is 45, and this is 4C, and this is 45, and again T, it is 54, like that. Right, this is hexadecimal, and once you do this, right, 45, for example, this is the hexadecimal you found out, and you can easily represent using ASCII codes. ASCII code is nothing but 7-bit code. Right, as I said, 421 and 8421, 8421. Right, you can see 4, how will you represent 4? It is 100 in 421. Right, and similarly here it is 01001. Right, so if you combine all those things, this is 1000101, that is 45. Similarly for 4C, similarly for 45, similarly for 43, like that. You have to convert all the numbers, hexadecimal numbers, to binary. So the ASCII code for electronics is, this is the ASCII code for electronics. Right, similarly any particular word, any particular letter can be converted to ASCII code. You can see binary, you got to write the corresponding hexadecimal value, 49, 4E, 41, 52, 59, and 42, how will you write in ASCII code? First is 421, so I represent 100. Right, and for 8421 it is 0010. So you can understand this, 1000010. Right, so this is how you have to convert any particular characters into an ASCII form. Right, so today what we have seen is, we have seen what is ASCII codes, what is the importance of ASCII codes, and we have seen what are the representation for ASCII codes, how it is represented. From A to Z, you got to start from 41 to 5A, and for small a to Z, it starts from 60 to 7A, and for numbers it's 30 to 39, and we have seen how to convert a particular character to ASCII code. Hope you understand the logic, right? So any particular question is given to convert ASCII to binary, ASCII to decimal, you can definitely do it, right? Thank you.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.